guys, welcome back to my channel. I do LeetCode problems and tech related stuff on my channel. So today we are solving delete node in binary search tree. As the exams are approaching, I'm trying to get to the topics that are gonna be in the exam for the data structure and algorithm question. So today question is, given root of the binary search tree and a key, delete the node. Return the root node reference, possibly updated of the best. So basically we have to delete a node in a binary search tree. So let's say this is a binary search tree and then the node tree is given, then we have to delete the node tree. So there's two scenario basically. Scenario one is if there's 0 leaf node and 1 leaf node. In that case, we can delete it easily. Let's look at this tree and look at this leaf node. There's no leaf node after this one. So how we're gonna do is we can just return, if we just check, we just go to this node and then we just check if it has the left node. If it's null, then we just return the right node. Otherwise, we just check if it has the right node, then we just return if it doesn't have it, then we just return the left node. That's in the case of 0 to 1 leaf node. But in the other case, when you have two children and we remove this, we need to find a successor in this case. Okay, so how can we find a successor? For example, successor, in this case, has to be, you have to find two ways. There's two ways to find successor. The first way is you find the minimum node from the right subtree as a successor. The second way is you find the maximum node from the left subtree of the root. So that's the second way. So we're just gonna use the right subtree and find the minimum node from the right subtree as a successor, okay, to delete the node. So let's just start it. We're gonna use recursive function. We're gonna use Java, but you could code in any other languages. No problem with that, okay? So let's start. If root equals null, you can apply the same solution for Python as well. It's exactly the same, okay? You just have to understand the concept. If root equals null, we just return root. Otherwise, we go to the process, okay? If root dot val is greater than key, the key that we have to find, if root dot val is greater than key, that means key is less than roots. If root, the value of root, is less than key, then the value has to be on the left side of the tree. So root dot left equals delete node root dot left comma val. So we just traverse into the left subtree of the node, of the root, okay? Else if root dot val is less than key, that means then the key has to be on the right side of the tree, okay? Right subset of the tree. So root dot right equals delete node root dot right comma val, right? Otherwise, in this case, else, that means we found the node to delete, because if it's not less and if it's not more, then it is equal, right? That means we found the node that we want to delete. In this case, we're gonna check, we're gonna go, like we said, we're gonna have two scenarios to delete. Remember, if it has a 0 to 1 node, leaf node, then we're gonna use if root dot left. If it has if the left node of that node that we want to delete is empty, that means we return the right, okay? Root dot right. Else if root dot right equals null, if the right node of that node is empty, then we just return root dot left. This is the case for single or zero node, okay? Single or zero node. If we check that's left side, if both sides are empty, we're just gonna check if left side is empty, then we're just gonna return the right side, which is empty anyway, right? Then else, what are we gonna do? We're gonna find the successor, remember? So tree node to replace the node that we're gonna delete. All right, we're gonna find the successor. Tree node. So how do you spell success? SUCC. Successor node, okay? Equals find min node. So we don't have this method yet. We're just gonna write it down after we finished it. Okay. What this method gonna do is just gonna find us the minimum node from the right side of the tree. Root dot right. We're just gonna pass in root dot right, and you will find the minimum root from the right side of the tree, whichever tree. And then what are we gonna do? We are at the root at the moment. So root dot val. We're gonna set the value of the root to the successor minimum dot val. the successor node is from the right subtree, minimum node from the right subtree, right? So we're going to use that, and we're going to set the value to the one we are deleting, which is right now we are at the root node, which is the one we're going to delete right now. So we're just going to take the value of the successor node, and we're just going to assign it to the root value that we are deleting right now. And then root dot right equals delete node. And then we're going to pass in delete node again, recursive. We're going to do root dot right, and then we're going to do successor node dot val. So we're going to pass in this root dot right subtree, and then we're going to ask the pass in recursive this value to delete it. So if it comes back again, then it will find that one side of the node of the root is empty, so it will not come into this again. So you can see the code, because it's gonna check if the root dot left is empty, that it's gonna return root dot right. So it will not repeat and delete another node. Okay, so find min node, this method gonna return a tree node, public tree node, find min node, and then we're gonna take tree node root as an argument parameter. Then we're gonna do tree node current equals root. We're gonna use while current is not equal to null, and current dot next is not equal to null. We have to check both conditions. Okay, we know current equals current dot left. So to find the minimum node of a binary search tree, you always have to go to the leftmost side. The leftmost node is the minimum node. Okay, so we just kept going to the left side, and then we just return the current. So since we pass in this root, we pass the right subtree, we'll find the minimum node of the right subtree. Okay, and then that's it. We return root. Pretty much we run the code. Hopefully it doesn't fail. Well, it always does. No, it's not current.next, sorry. Current.left, because I'm stuck with linked list. Okay, current.left. So what else? I cannot find some of the delete node. Val, line 29. It's not 29. Oh, it's key. It's key, guys. It's not val. Okay, it's key. Sorry about that. Let's run again. Yep, we got the output. We submit this. Accept it. 0 millisecond, beat 100%. So the runtime would be to find this. This is locked n, okay? Because we need to go. We can say locked h, okay? H is the height of the tree. We could say locked h to find the minimum node of the tree, locked h. And then for this one is also locked h, because we have to go from we find out if it's less than or greater than the root, and then we traverse through that list. If it's left side, then we go to the left side. If it's right side, then we go to the left side. So half of it is already, this is also locked h. So both of them are locked h. So you can say the runtime is locked h. Okay, if it's a balance, when we say balance binary search tree, it's like we don't have like a lot of chain linked here, like just like balance, in general, like most tree. So that's all for today, guys. Thank you very much for listening, and good luck with your exams if you have exams, and happy coding. Thank you for watching.